And first law of thermodynamics can also be used in finding the relation between two principal specific heat of gases, which is specific heat at constant pressure and specific heat at constant volume. Okay, Cp and Cv. This is also called Mayer's formula. Okay, Mayer's formula. So let's start it out. Let us say, consider that P, V, T be the initial state variable of this gas. We have considered 1 mole of ideal gas. The word ideal is very important right now because we are going to take a lot of assumptions. Now PVT is the initial state of this ideal gas. Okay, what we are going to do, we are going to first calculate that let the gas be heated at constant volume, let us say. Okay, at constant volume, what will happen? Amount of heat dq is equal to what? mc theta or mc delta t. M is what? 1 gram mole of gas, that is 1. C is specific heat at constant volume, and theta is the change in temperature dt. So Cv dt is dq. According to first law of thermodynamics, dq is equal to du plus dw, whereas dw is what? pdv, but we are doing it at constant volume. So this term, which is basically pdv, will comes out to be 0 because there is no change in volume. That means dq is equal to du, right? So replace dq by this term, which is Cv dt. We get Cv dt is equal to du. This is equation number 1. Now we are now heating the gas at constant pressure. At constant pressure, what will happen? Again, dq, let us say it is dq dash, is equal to what? Nc, what is the formula of heat? Q is equal to mc theta. M is 1, C is a specific heat at constant pressure, and change in temperature is dt. Now according to the law, dq dash would be equal to du dash plus dw, right? Now dq dash is this, which is Cp dt, which is equal to du dash, because I am writing dash everywhere because we are doing it for what? We are doing it for change in the gas, the change in temperature at constant pressure. This was at constant volume, so you can write it out here. This is for constant pressure. This would be the formulas, right? Now Cp dt is equal to du dash plus dw dash. What is dw dash? At constant pressure, pdv will have some significant value. dw dash, which is pdv, is not going to be 0, right? So I am replacing this word dw by pdv. So I'll get Cp dt is equal to du dash plus dw dash is pdv. This is very clear. Now what is the change in temperature? We are changing the temperature in both the cases at constant volume and constant pressure, exactly same. dt is the small change in pressure, let it be the same value or same degree Celsius, right? So that means when same amount of temperature difference has been created in both the cases, internal energy is going to be very equal, because internal energy for an ideal gas is only dependent on the change in temperature. So du dash would be equal to value of du, which is Cv dt. Put du dash here. Instead of du dash, I am writing du here, and instead of du, I will be using Cv dt. So what I am getting is Cp dt is equal to that thing, Cv dt plus pdv, right? Now this comes out to be Cp minus Cv. I'm bringing this term here, so I'll get Cp minus Cv times dt is equal to pdv. Now according to ideal gas equation, what do we have? pdv is equal to nRT. What number of volts we have? PV is equal to nRT, right? Don't confuse with that. PV is equal to nRT. But what is the change in volume we have considered right now, which is dV? Pressure is P, and number of volts is 1. R is R, the gas constant, and T is right now dt. So basically pdv, it was 1 which I omitted, so pdv is equal to R dt. Put R dt here. So Cp minus Cv times dt is equal to R dt, and cancel out dt from both sides. I'll get Cp minus Cv is equal to R. This is the relation between specific heat capacity at constant pressure and specific heat capacity at constant volume, and the difference is the gas constant. This is called Mayer's formula.